So, good evening, everyone. Today we will be discussing a topic on electrochemistry. So, since I have chosen this topic because many questions came from this electrochemistry part in recent years, and this is one of the important concept in chemistry, and I felt that many of you may be lacking the concepts. So, the first question which I wanted to discuss today is of GATE Xl-P 2020, question number 13. So let us first read what the question is stating. The standard potential inert cell for a cell reaction given below is plus 0.7 volt. The standard reaction free energy, that is delta R G naught for this cell, is kilojoule per mole they are asking, and they are also asking to correct up to two decimal places. They have given the value of Faraday constant, which is 96500 coulomb per mole. And there is this equation or this redox reaction which is been given here between the gold and the silver. So here you need to first at least know about what is a standard potential of a cell, what is a electrochemical gradient, and what is a standard reaction free energy to solve this question. So now first let us look into some basic concepts of this electrochemistry question. First is what is Gibbs free energy and of E cells. Okay, so what is the Gibbs free energy that is being asked here? That is the standard reaction free energy. You can also see from the question. So it is the maximum cell potential that is directly related to the free energy difference between the reactants and the products in the cell. So there in this question, if you see, there are these reactants and the products. So what is the free energy difference between the products and the reactants that is given by this standard reaction free energy, that is delta R G naught. This is given by the formula of delta G naught equals to minus N F epsilon naught, okay, or E naught. So this E naught is the electrochemical gradient at standard conditions. Okay, so this there means the this electrochemical potential is this E naught, which is given by these volts. That is this work per charge. That is work is coming in joule. Joule per charge is the volt, and this is the unit of this electrochemical potential. Okay. Now what is this N? N is the number of moles transferred per mole of reactant and product. So in the reaction, in the chemical reaction, how many effective electrons of or the number of moles of electrons is being transferred is given by the form or by the symbol N. And what is F here? F is the Faraday's constant that is already given in your question, that is 96500 coulomb per mole. Okay, so this is the basic idea or the basic formula that you need to know in order to solve this question. Okay, now so what will be the solution of this question? So let us look into the solution, and I will more describe about what is N and how you can calculate it. Okay, so it is given that the electrochemical reaction is this. So in this kind of question, what is very useful for you to do is that first write the electrochemical reaction that is going on this cell. Okay, and then what is a good practice to do is that first to balance the equation. So if you write a electrochemical equation or the reaction, and if it is not balanced, then you may end up in a wrong answer. So first you need to balance the reaction that or the equation that you have written. So this equation first I have balanced because of this 3Ag and 3Ag plus. Okay. Now calculate that for each of the reactant, what is the difference in their oxidation state. So here the oxidation state of gold is 3 plus and here it is 0, right? So now if you check that this is the 3 plus to 0. Now if it is the difference between them is 3 or minus 3, if you take difference between the product to the charge that is present in the product that to the reactant, then it will be minus 3, and if it is reverse then it will be plus 3. Okay, what it means is that the charge is getting reduced here, means the Au3 plus is actually getting reduced, whereas this 3Ag it is getting oxidized. So what is the oxidation number, means how much charge difference is there between two entities of the reaction. First you need to find that. If it is different, like here in the case it is 3 and 1, then multiply this 3 with the 1 and you will get the n value. But suppose in this reaction, in this equation, if it was 2 and 2, both of them were 2, means the net 2 electrons were actually transferred in this reaction, then the n value would be 2. So the basic idea or a trick by finding the n is that in short period of time is that first you need to calculate the oxidation states of this each of the entities of your reactant and the products. And then if you find the both the entities of your reactants are the difference between the oxidation states are same, then the value which is coming, the difference which is coming is the n value. If there is a difference between them, means if it is like this 3 and 1, then you need to take the LCM or you need to just multiply both of them to get your n value. Okay, once you get the n value, then the question is very easy, because now you also have to know this formula, that is del G naught, or that is this naught is for the standard potential, this is E naught is the standard potential and this is the standard free energy. What is been asked in the question, if you see the question, they are asking you the standard reaction free energy. Okay, so the standard reaction free energy, as we have discussed here, that this is given by the formula equals to minus n f epsilon naught, where the epsilon naught is the standard potential. Now if you put the values here, so E naught cell is given, that is plus 0.7 volt. This is already given in the question. Now what you need to find out is this del G naught value. N value you got by solving like this that I just discussed with you. So now the N value will for this question will be 3, and the Faraday's constant is already given, that is 96500 coulomb. Now just you need to substitute these values in this equation to get the answer, that is this del G naught value will be here minus 202.65 kilojoule per mole. Okay, so this is one of the question that I wanted to discuss with you. What is important in this question is to look into that the equation, the electrochemical equation that is being provided to you. You need to first look into it carefully, whether it is balanced or not. First you need to balance it. Then you need to find what is the oxidation state of your reactants and your products. Now what you need to do is to take the difference of the oxidation states of these reactants of these products to the reactants or reactants to the products. If the difference value is coming same, means net that much amount of electrons is being, or that much moles of electrons has been transferred in this electrochemical reaction. But if the value is different, then what you need to do is that you need to take the LCM or you need to just multiply the two values to get to your n value. Once you get the n value, then the question becomes quite easy, since you need to just put that value into this del G naught equation and get your answer. So two things are important in this question. First is to find the n value, and the second thing is to find the del G naught value, which you need to first remember the formula, that is del G naught equals to minus n F inert cell. What is inert cell? Cell is the electrochemical potential, that is the potential difference between the two electrodes. So in a electrochemical cell, there are two electrodes. One is anode and one is cathode. Normally this anode is positively charged and this cathode is negatively charged. In the anode, the oxidation state takes place, whereas in the cathode, the reaction takes place. Just like in this reaction, if you see this gold or this Au3 plus, it is getting reduced into Au, and this silver is getting oxidized into Ag plus. So two kinds of redox reactions occurring into two electrodes, and the difference between the difference between the potential in these two electrodes is given by this electrochemical potential gradient, or this, if it is in a standard condition, then it is stated as inert cell. Okay, and what is the difference between the free energy of your product and the free energy of your reactant? That is given by this del G value, and if it is in a standard reaction or the standard nature like inert cell, then it will be standard free energy. So the answer of this question, the question of this XLP 2020 question number 13, is minus 202.65 kilojoule per mole. So for your reference, you can actually follow these two courses which is offered by NPTEL. So the first course is of elementary electrochemistry, and the course instructor for this NPTEL course is Professor Anshuman Roy Choudhury of Aizer Mohali. The link is been provided here. Another course is run by NPTEL, that is the name of the course is electrochemistry, and it is the course instructor of this course is Professor M.V. Sangaranarayanam, and he is from IIT Madras. So you can look into these two courses for your better insights in about the electrochemistry and get some more idea about the electrochemistry concepts, which will be very useful for your GATE exams.